Okay, so we are in module 4 of our course, right? And today our focus is on virtual private cloud, right? So essentially, we want to look at networking services today, and the main one there is virtual private cloud. Okay, so today, what we'll do is we'll try and understand what what a VPC is, and what has happened is what happens is a lot of us come from application backgrounds or system admin backgrounds, development backgrounds, right? So we understand things like web servers, database servers, etc. But but we don't really know much about networking. Right? We don't know about networking because the networks are usually set up by someone else, right? Some other department, and a lot of people don't have familiarity with networking concepts, right? Now the cloud changes that. Right? The cloud changes that because you have to set up your stacks in, the networking bit also has to be handled, right? Especially if you are concerned about security, right? So virtual private cloud, first of all, private cloud, right? It's basically where you have your own private network. Right? You have a private network. Often, private cloud also uses dedicated infrastructure, right? So it's mainly two things. Do you have a private network instead of a public one, and do you have dedicated hardware, right? So that's what private cloud is. And a lot of people are saying, look, we need private cloud-like capabilities because there are regulations which require that we use dedicated hardware, or even if that's not required, at least we want our own private network, right? We don't want it to be exposed to the internet where it is more vulnerable, right? So that's what a VPC is. And now what is happening is AWS has realized VPCs are a better way than what used to happen. So VPC is a relatively new service, right? And before VPCs, the servers were deployed in the public cloud, right, where anybody could access those servers if the firewall rules allowed that, right? But VPCs are a networking feature where you create your own private network, right? And then you can choose to make that some parts of that open to the internet, right? You can choose that, or you can keep it completely private as well, right? So that's what a private cloud is. It's called virtual because a private cloud, normally going by the strictest definition, it's your own equipment, own data center, right? So it's owned and operated and controlled by your company, right? That's what a private cloud really is. But this one is still owned and operated and controlled by AWS, right? But it has the characteristics of private cloud, and that's why it is called virtual private cloud, right? So that's what a VPC is. And what's happening is AWS especially is realizing that this is a better way, right? People want this feature, and they're making it the default way, right? So all the servers, the RDS instances, etc., that you set up will now have to be set up in VPCs, right? So it becomes a very important topic. And like I mentioned, people are not familiar with networking that much, right? Given the history, given how things used to be done in the past, right? So it becomes an important topic, A, because you have to use it, and B, because you're not really familiar with it, right? So this needs a little bit of work, is what I'm trying to point out, right? If you don't understand this fully right away, don't be discouraged, right? Don't be discouraged because we are all in the same boat, right? We all are trying to learn networking, look at networking anew, afresh, because we need to when it comes to cloud computing. All right. Okay. So what we'll try to understand is some networking aspects, right? Let's understand what a subnet is. What is a subnet mask? What is a VPC and why? Why is it important? Right? What are its benefits? And then we'll get into the implementation details. For example, there's a non-default VPC, there's a default VPC. There are very many components of a VPC. There's a routing table, there's an internet gateway, there's a NAT gateway, there's an access control list, lots of stuff, right? There's lots of different parts of a VPC which you need to understand. And then fortunately, there's a wizard, right? There's a VPC wizard which makes it easy to create a VPC. So we'll use that and actually implement a virtual private cloud, right? So that's what we do. And we'll also take a look at one more networking service, right? Which is again, we're trying to find a balance between enterprise and non-enterprise, right? So VPC, this Direct Connect is an enterprise service, and this can be used to create a dedicated connection, like a leased line, between your corporate network and the cloud. So we'll talk about this later, but our focus today is on virtual private cloud. All right, now let's look at some networking concepts, because this is important to understand before we look at VPCs. Okay, so a subnet, right? A subnet, VPC, by the way, VPC is basically a network. Right? It's a network, which means you have many IP addresses within that network. It's a private network, so the IP addresses don't matter, right? You can have any sort of IP address because it's your own private network. Nobody else needs to know about it, right? And within a VPC, you have a subnet, which is basically a sub network, right? It's a smaller part of the VPC, right? And the IP addressing of these things needs to be understood, right? So basically, a subnet is a smaller part of the network where all the IP addresses have the same prefix, right? They have the same prefix, and there's a subnet mask, right? That will determine the size of the subnetwork as well. Okay, so let's look at how the subnet mask works, right? So the subnet mask basically has two parts. It has a network address and a host address, and the mask will determine the size and the IP addressing of the subnetwork, right? So let's look at this. I think this slide is better, right? So what you have is you have the subnet mask. You might be familiar with this, right? You have a common subnet mask used is this last one here, 255.255.0, right? So this is a commonly used mask. You will see it in many places, including your home network, right? This is what you will see as the subnet mask. But this is class C subnet, right? There are other masks as well. So class A is a really big network, right? Class B is somewhere in the middle, and class C is what we normally use in our companies and in our homes, right? So the way the subnet mask works is there's network. Some part of the mask is used for the network identification, and the rest are used for the host identification, right? And basically, let's keep it simple. Don't worry too much about it, right? If you see a mask like this, you probably will not, right? Because it's a very big network. This is a class A network, and it has close to 16 million hosts, right? 16 million IP addresses can be fitted into this network, right? And by the way, this mask applies to VPCs as well, right? So it's not just for subnets. The mask applies to the whole network as well, right? And class B networks will have about 65,000 IP addresses, and class C will have 256 IP addresses, right? 2 IP addresses are reserved, so you effectively get lesser IP addresses, right? So just remember that there are 3 types of networks depending on the subnet mask, and these 3 networks can be very big, 16 million, or it can be small, which is 256 IP addresses, right? So what we do mostly is in the VPCs, we set up subnet masks with class C, right? And the VPC itself is a class B, and within the VPC you can have 1 or more subnetworks which are class C networks, right? So that's how it works. Okay. Now let's look at VPCs, and let me just also point out one very good resource, right? I like to use this. Just look at CIDR Wikipedia page, like very good Wikipedia page, and this talks about all this, what's a subnet, what's a subnet mask, right, and how all of this is calculated. These are not AWS topics, right? This is networking concepts, and this explains everything very well. And you can especially look at this table here, right, where this is your subnet mask, right, and it translates to how many IP addresses, right? So for example, if you look at /16, right, /16 translates to this subnet mask, 255.255.0.0, right? And this gives you 65,000 IP addresses, right? So this is the class B address, and this is the one that is used for VPCs, right? And if you look at /24, this translates to this mask, 255.255.255.0, and this gives you 256 IP addresses, right? So you can also have other types of masks, but broadly we'll be using this one, /24 and /16, right? So this network mask is what we've seen in the slides, right? But another way of looking at the mask is to look at /24 or /16, right? So this /24 is the CIDR notation. Right? So it's a different way of specifying the same network mask, right? So so you can look up this document when you find time. All right, now let's get into VPCs a little bit more. Let's understand this a little bit more. So what we're doing really is you're creating private network on the cloud. Private network on the cloud. It's like, you know, your own network in your own data center, except the only difference is that this network is in the cloud in AWS data centers, right? And then you can connect to it, right? You can connect to it from your corporate network using a VPN connection, right? This is an encrypted connection between your corporate data center and the cloud. Right, so this is basically what a VPC is. Now you can also open up your VPC to the public, you know, on the internet, right? So you may run your websites, your web applications on the private cloud, and some parts of your application, especially the web server, right? You can open it out to the public, right? So it's not that this is a private network only, right? You can have some parts of it to be public. Right? But otherwise, the major aspects, the sensitive aspects of your application in your infrastructure, your application servers, database servers, etc., can be kept in the private subnets, right? And only the public stuff like web servers can be opened out to the public, right? So this is broadly what a VPC does. It's a better way than using plain public cloud, right? But it also increases the complexity. Right? You need to learn these things. All right. So the way this works is, you know, what you do with the VPC is you can, you know, you can basically launch your EC2 instances, RDS instances, etc., in the same way that we've seen so far in the course, right? So that doesn't change, except that you'll be launching your servers in the VPC, right? And the VPC gives you some additional advantages. So what you can do is you can create your own IP address range, right? So that whole flexibility of creating your own network is available with you. You can create route tables. These route tables determine, you know, how the traffic can flow within the network, within the VPC, and also between the VPC and the external world. So you have control. You have control over the routing of the network traffic. Okay. You can also create what are called internet gateways, and you can attach them to subnets. And what happens with internet gateways is that internet gateways can be used to connect to the outside world, right? And you can also allow the outside world to connect to some of your servers, right? So this internet gateway is the one that makes it possible for people outside from the internet to connect to your servers. So so maybe you have your web application or your website which you want to make public, right? Then you have to use the internet gateway, right? So this is what opens out your VPC to the internet, right? You can have multiple subnets, right? You can have many subnets, some public, some private in the VPC. So so you can handle this layering. You also have security settings which are better in VPCs. So for example, you have security groups which we've seen so far. Right? We've seen the firewall that we attached to the instance, and in addition, there's a network level firewall as well. And that's called access control list, right? So there are two layers actually. There are two firewalls, one at the resource level, servers, databases, etc., and then one more at the network level, at the subnetwork or the VPC level, right? And of course, you can also connect. You can connect to the VPC using VPN, right? Using a VPN, which is an encrypted communication between your corporate network and the VPC, right? So you can see here, right, you have more control over networking using things like routing table, custom IP addresses, etc. You can choose to open out VPC to the cloud, to the public internet or not, right? That's another benefit. You have multiple security layers, and also you have encrypted connection to your VPC, right? So you can, I hope you can see that it does give you those additional security benefits. Right, so that's why VPCs are becoming the default. Right, we all have to use VPCs, even though they are a little bit more difficult to learn. All right. Okay. Now there is, you know, now AWS is aware. Right, AWS knows that people are struggling a little bit with VPCs, right? So what they've done is they've created a VPC. They call it the default VPC, and this is pre-built, right, ready-made. If you go to the VPC console on your AWS console, you'll find there's an existing VPC already there, right? So that's called the default VPC, right? And the reason they made this is because they want people to get started with setting up their EC2 instances, RDS instances, etc. And you can quickly use the default VPC, right? You don't have to create your own VPC. Just use the default VPC and set up your servers, and everything will work fine. And the reason it works fine is because the default VPC has very loose rules, right? So the firewall rules, the access control lists, etc., are quite open. So the default VPC is easy to use, right? The default VPC is easy to use. Now, so when you're learning, you can use the default VPC, right? But otherwise, don't. Otherwise, don't, because it's not really meant for production use, right? It's not meant for production use. So this is very important, right? Use the default VPC when you're getting started, when you want to focus on learning EC2, RDS, etc., right? But for production, you have to create your own VPC, right? So just remember these two. Remember what a default VPC is. Don't use it for production. All right. So there are some differences. There are some differences between default and the non-default VPC. For example, in the VPC, you receive a public IP address by default, right? Whereas in the non-default VPC, you don't. And this is, you can see right away, there's a security issue. If you set up an EC2 instance in a default VPC, it has a public IP address which anybody can connect to, right? Now, you may say, look, I don't want that, right? I don't want my servers to be accessible to anybody on the internet, right? I'm going to create a VPN connection, right? So what you really want is, by default, no public IP address, right? And then if you want a public IP address, you can assign that manually, right? So you can see here right away, the difference is the default VPC is meant for convenience, right? It's meant to be easy to use, especially when you're learning and you're doing some proof of concept, etc., right? Whereas the non-default VPC is designed to be more secure. All right. Okay. So also, the other thing is the instance can access the internet, right? So the default VPC has an internet gateway that by default allows access to the internet in both directions, right? So someone from the outside can get into your VPC because this is enabled by default, right? Whereas that's not the case with non-default VPCs, right? Okay, so that's it. Don't worry too much about details, but the main thing is this is for learning purposes only, right? You need to create your own VPC when you're ready to move to production. All right. Now, within a VPC, you have security groups, which are the same as what we've seen before, right? So whenever you launch an EC2 instance or an RDS instance, you need to attach a security group, right? That's mandatory. And the security group has basically rules about what kind of traffic is allowed in, right? Do you want SSH connectivity allowed? Do you want HTTP connectivity allowed, right? So the same security groups are also available within VPCs, right? And they're basically used by resources like EC2 instances and RDS, right? Okay, now there are some other components as well that you need to know about. So for example, within a VPC, you have subnets, right? And the subnets can be of two types, public and private, right? Public subnet can be accessed from the internet, right? Someone can connect to servers in your public subnet, right? Whereas a private subnet is what it says it is, right? You cannot connect to it from the internet. You can connect to it indirectly or using a VPN connection, but not from the internet, right? So this is one. Access control list is a firewall which is at a network level, right? This is in addition to the security groups that are already there, right? Okay, there's routing tables. We talked about it. It's basically used for determining how the traffic can flow within the VPC and also between the VPC and the outside world. So this we have to look at. And there's a bunch of other things. So NAT gateway, right? Internet gateway, virtual private gateway. So these are sort of components. These are sort of components which are used for communication between the VPC and the outside world, right? So the internet gateway is the one that is used to make a subnet publicly available. So if you have an internet gateway associated with your subnet, then the traffic to and fro between the internet and your subnet can happen, right? So that's internet gateway. A NAT gateway is used by private subnets to only on the outbound side, right? So let's say you want to install some software patches, your servers can connect to the internet to download those software patches using a NAT gateway, right? So there are these components which are used for connectivity. There's something called virtual private gateway as well. So this is the one that is used to create a VPN connection between your VPC and your corporate network, right? And then there's also VPC peering, which is used to connect two different VPCs, right? These two different VPCs can be within your own account, or they can be VPCs which are not in the same account as well, right? Okay, let's look at this. So first of all, IP addressing. There are private IP addresses and there are public IP addresses as usual, right? You know this already. Private IP is completely internal. Nobody knows about these IP addresses. If you know a private IP, you can't connect to it from the internet, right? There's no way to find out where that IP address is, right? So you use private IP addresses mainly for internal communication within the VPC, right? A public IP address is reachable over the internet, so you use it for communication from the internet into your servers, right? So your web server, for example, will need a public IP address. All right, okay. Now a subnet, right? A subnet can be private or public, like we discussed, right? And what happens is the internet gateway is the one that determines whether a subnet is public or private, right? So if a subnet has an internet gateway in its route table, then it's a public subnet, right? Otherwise, it's not. Right? So please remember, internet gateway, right? It's the only thing that determines if a subnet is public or private. All right. Okay. Route tables and access control list. So routing tables are basically routing tables, right? You can set up some routing rules, and the rules determine how the traffic will flow, right? So I'm going to show this to you, and I think it'll be easier to understand. But each subnet will have a route table associated with it, right? That's a mandatory thing. Each subnet must have a route table, and the route table determines whether or not there's an internet gateway, right? Whether or not there's a NAT gateway, and that determines how the traffic can flow to and fro from the subnet. All right, and ACLs are a firewall, right? An additional firewall at the network level. All right, let me stop here, right? My sense is, this is a little bit tricky, a little bit complicated, right? Let me see if you have any questions on what we've seen so far, right? Remember, we've discussed things like subnets, subnet mask, VPC, and then the various components of VPCs like ACLs, internet gateways, NAT gateways, etc. Right? Any questions so far? I just want to make sure that this is not too complicated, right? And of course, I'll be showing you these things, right? I'll be showing you these things so it'll become clearer when you see them, see these things in action. All right, I'll come back to Ranjit. I'll come back to this question later. Let me just focus on the network side, right? So a difference between direct connect and site-to-site VPN. What are the costs for both? In private cloud, we have separate team for storage, network, etc. So what is expected for a person to do this course? All right, so okay, there are multiple questions here. So let's look at these questions one by one. So direct connect versus VPN, right? Direct connect is actually you're bypassing the internet, right? So you're bypassing the internet. So direct connect is what it says it is. It's a direct, dedicated connection, right? Dedicated connection to AWS, right? So you bypass the internet, right? So that's a connection, right? A VPN is just a technology, right? VPN is just a protocol, right? For encrypting the connection between your network and AWS, right? So what actually happens is if you use the internet, right, you can use VPN to secure it, right? And also you can also use a VPN with direct connect, right? That's also possible, but it may not be necessary because it's not a public network, right? It's a dedicated network, so it's not necessary to use VPN with direct connect, right? So these are not competing things. It's they can complement each other as well, right? Okay. Cost, you can look it up, right? Cost is something you can look it up. It's just very simple to find this. For example, you can look up the costs of direct connect. Right? So the cost of direct connect is something like, on an hourly basis, right? And also depends on the speed that you want. So for example, 1 gig per second, right? You get the cost is about 30 cents per hour. So these are the kinds of costs you can look it up, right? The second question is, in the private cloud, we have separate team for storage, network, etc. So what is expected for a person doing this course, a master or jack of all? No, so this is a solutions architect course, right? So you need to know enough. If you want to architect, if you want to design these things, if you want to make decisions for your company, right? You don't need to master all this, right? You don't need to be a master of deployment or implementation of these things, right? Which a network administrator, database administrator, system administrator can do, right? What you need to know is how all this works, right? How all this works. What does it cost, right? What are the trade-offs, etc., right? So you can decide, right? So you can make decisions around the design, around the architecture, right? So that's what a solutions architect does, right? You need to know enough so that you can actually make decisions for your organization, right? You don't have to necessarily implement all this, right? You have to take some decisions. All right, and then is it not possible to keep a web server in private subnet and the ELB in the public subnet? Yes. So if you use ELBs, right? If you use ELBs, then yes, then the ELB can be in the public subnet and the web servers in the private subnet. Yes. Right, but if you don't use ELBs, then the web server becomes the first layer, right? So then the web server has to be in the public subnet, right? So if you don't have ELBs, by the way, for the benefit of others, ELB is elastic load balancer, right? So you use load balancers when you have multiple servers in your web tier or application tier, right? So the ELB is distributing the traffic to the multiple servers. So if you don't have ELBs, right, then the web server has to be in the public subnet. All right, okay. So AWS will set up a direct wire line to my data center if I use direct connect. Yes, that's the idea, right? That's the idea. Check out, direct connect may not be available everywhere, right? So check out if it is available, in your location, right? And also the last mile, right? You may need to talk to an AWS partner for the last mile, right? And you have to figure out the costs, the service costs, etc. of the last mile. So I'm not very familiar with it because I've not really done it myself, right? But the general idea is the AWS Direct Connect. There will be some locations, right, where AWS Direct Connect will be available, and then the last mile is a complicated bit, right? You'll have to speak to somebody. They have partners, right? This AWS has a partner network. You'll have to speak to some partner who and figure out what's the best way to connect the last mile, right? But yes, the idea is what you say, right? Which is to set up a wired line dedicated connection from your corporate network to AWS. All right. Okay. So let me continue here, right, with VPC, and we'll see this as well. Okay, so NAT, right? NAT is network address translation, and you normally want to use something called a NAT gateway. This is used by servers in the private subnet to go out to the internet, only on the outbound side, right? Because private subnet servers also need to connect to the internet for things like downloading software patches, right? So the NAT gateway is the one that lets you do that, right? Remember, internet gateway to make the subnet public, right, where anybody can access your subnet. A NAT gateway is used by private subnets only for the outbound traffic to the internet. All right. Okay. Now there is a NAT gateway and NAT instance. NAT instance used to be there, and now there's a gateway service, right? So I always recommend that you use the gateway because it is fully managed, scalable, much simpler to use the NAT gateway, right? NAT instance. If you want to have control over the NAT, right? I don't know why you would want to do that, right? But it's an option available, right? So a NAT instance is basically an EC2 instance that comes up, and you have to manage, you have to make sure it's always up and running, right? Whereas a gateway is more of a managed service where everything is done for you by AWS, right? So my recommendation is that you use the NAT gateway. All right, okay. Now there's also peering, right? There's also peering. So sometimes you may want to have you may have two VPCs, right? And there may be a need for connection between the two VPCs, right? So then it's not easy to make them talk, right? Because remember, these are private networks, right? Their IP addresses are private IP addresses from one VPC, right? Even if you know the IP address of the other, you can't really connect because these are private IP addresses, right? So what you need to do is to create a peering connection, right? You need to set up peering between these two networks to make them talk to each other, right? So for example, let's say you have VPCs for each department in your company, right? The finance department, your HR department, and they have some applications, and there's a VPC for each department, right? And sometimes there may be need for communication between the two types of applications, right? So there you'll probably create a VPC, a peering connection. All right, okay. Internet gateway, like I said, it's used to make the subnet a public subnet so that people can access your subnet from the internet. All right, so these are some terms and terminologies and components, right? I know this is a little bit of a difficult topic, right? So don't be discouraged, right? Don't be discouraged. Let's take a look at this. Hopefully, it'll make things better, right? So thankfully, there's something called the VPC wizard, right? The VPC wizard. And the VPC wizard can be used to create different types of VPC scenarios, right? And there are four common scenarios. Right? There are four common scenarios, and we'll probably look at maybe one or two of these today, right? But let's talk about these scenarios a little bit. The first one, this is a VPC with a single public subnet, right? VPC with a single public subnet, right? And what can you do with this? You can maybe run a web application on a server, right? And that server will be in the public subnet, and anybody in the world can connect to your web server and use your application, right? So this is a very simple scenario of a VPC, right? Scenario 2 is pretty good as well. Here you have one public and one private subnet, right? And what happens is your web servers will run in the public subnet because you want people to access it from the internet, right? And your database servers or even application servers can run in the private subnet because you don't need anybody to connect to it, right? You don't need any person to connect to it from the internet, right? It's your own private server, right? So you have your databases, application servers, and any other component in the private subnet, and only the web server or the load balancer, if you're using it, to be in the public subnet. Right, so this is a good one. This is a good case where you have both public and private subnets in the same VPC. Right. Okay. Now scenarios 3 and 4 are similar to 1 and 2. Right. They're similar to 1 and 2, except they talk more about corporate applications where the applications are accessed mainly from your corporate network. Right. So for example, in scenario 3, you have a public and private subnet, and you use a VPN connection to talk to the VPC. Right, so that from your corporate network over a VPN connection, over an encrypted channel, you can connect to your servers. Right. In scenario 4, so scenario 3 is quite similar to scenario 2 actually, except there's a VPN connection out there. And scenario 4 is actually quite similar to scenario 1, where you have a VPC with a private subnet, right, and a VPN connection to that private subnet. Right. So scenarios 3 and 4 are mainly used for maybe internal applications, right? Internal corporate applications which are accessed mainly from your corporate network, whereas scenarios 1 and 2 are used for more public-facing, right, internet-facing applications that you may want to have, right? Okay, so these are the four scenarios, common scenarios, and there's a wizard which can be used to create any of these scenarios, right? So let me stop here. Let me show you some of these things, and hopefully it will become clearer. All right, let me sign into my console here. Okay, now I'm going to use a second factor device on my phone here, and this is something we'll talk about later, right? It's very important. You should have two-factor authentication on your account. All right, so this is the management console, right, which we are all familiar with. And now, if you look at the networking category right here at the bottom, right, you will find VPC is the first choice here, right? So let me click on VPC. All right. Now, if you look at the home page, right, you can see right away that there is one VPC already there, right? And this is the default VPC that we spoke about, right? So remember, we said there's a default VPC which is ready-made, already there, right? It's used for to help you get started with VPCs, right? It's easy to use, but you know, it's not very secure, right? It's not meant for production use. It's only convenience, right? So that's what this VPC is, right? And this VPC has a subnet in each availability zone, right? Subnet in each availability zone. That's why you see 4 subnets that are part of this VPC, right? By the way, folks, a VPC, right? It's very important to understand. VPC can only be within one region, right? It cannot span regions, and a subnet can only be within one availability zone, right? It cannot span zones, right? That's something important. All right. Okay. Now let's look at this VPC a little bit, right? Let's just see what it looks like. This is the default VPC, right? This is the default VPC. If you click on it, you get basic information, stuff like what is the IP address range, right? You can see here this has IP address of 172.30.00/16, right? /16, and this is the network mask, right? This is a network mask. And if you look at your CIDR notation table, right, you can see /16 actually means a mask of 255.255.00, which means there are about 65,000 IP addresses possible in this VPC, right? So a VPC itself is a network. It has its own network mask, and this is a large network, a Class B network, right? It's a Class B network with about 65,000 IP addresses, right? Okay, now this has subnets, right? And there's one subnet for each availability zone. There are 4 zones in this region, right? So if you go to any other region where there are only 2 zones, for example, you'll find only 2 subnets, right? So main thing is the subnet can only be within a zone, right? And the default VPC has 1 subnet per zone, right? Okay, now look at the if you look at these 4 subnets, right, you can see the IP addressing. This one is 172. This one is 172.30.00/24, right? The subnet mask is 24, right? And this 24/24 corresponds to a subnet mask of 255, 3 255s, right? And there are 256 IP addresses in this subnet, right? So that's all. That's what you need to know. That how many, what's a network? How big is a network? How many servers can I have, right? So all you need to know is a subnet is usually created. It's a Class C network, and usually you can have about 256 IP addresses in a subnet, right? So this is one aspect. Now look at the IP addresses, right? This one has a 172.30.00/24, right? The next one has 172.30.10/24, right? So you can see the network addresses are different, right? This will be, this has its own set of IP addresses, and the other one has its own set of IP addresses. There's no conflict. There's no conflict because they're all part of the same network, right? You can't have IP address conflict. So the subnets have different IP address ranges from each other, right? From each other. So because there's no IP address conflict, your traffic can flow easily between subnetworks in the VPC, right? So you can see here it's 00/24, 10/24, 20/24, and 30/24, right? So these are the different networks, right? All right. Okay. Now let's take a look at one of these subnets, and also for each subnet, let's look at these tabs here. Right? There's route table, there's network ACL, especially, right? Okay, and also the summary itself. Right? You can see the subnet has this subnet mask. It has about 256 IP addresses. Subnet is in this zone, right? It can only be within one zone, right? Okay. You can see here auto assign public IP address is turned to yes, right? So whenever you create a EC2 instance in this subnet, that instance will have a public IP address, right, by default, because the default VPC is easy to use, right? But when you create your own VPC, this will be no, right? You will not have IP addresses, public IP addresses for your servers by default. All right, let's look at the route table. Remember, we said there are route tables. Each subnet has to have its own route table, right? And you can see here there's a route table here where there are three rules here, right? And the first rule is the target is local, right? So what it says is, what this really means is that traffic can flow easily from one subnet to another. Right? Local traffic, intra VPC traffic is allowed, right? That's what it means. This IP address says 0000/0. This refers to all other IP addresses, including external IP addresses, right? So for external IP addresses, the target is the internet gateway, right? Internet gateway. So this is the one that allows traffic to flow between the internet and the VPC, right? And the presence of an internet gateway in the route table signifies that this is a public subnet, right? This is a public subnet because there's an internet gateway in the route table, right? Let's ignore this last bit for the moment, right? Let's only focus on these two rules. One is a rule for local traffic. The other is a rule for external traffic, right? And because there's an internet gateway, this subnet is a public subnet, right? Okay, so we've discussed VPC, we've looked at its network size, its network mask. We've seen that the VPC has 4 subnets, one for each availability zone, right? You can create more subnets, by the way, right? You can create many more subnets in the same VPC. That's not a problem, right? But the point is, each subnet can be only within one availability zone, right? Okay, now the subnet has its own IP address range, right? It is in one zone. It has public IP addressing turned on, right? The route table has internet gateway, which makes it a public subnet. All right. Now we also spoke about ACL. Remember, we said there are 2 firewalls, right? 2 layers of firewalls in our VPC, right? So this is the network ACL, the network level firewall, which is attached to this subnet, right? And this is a more sophisticated, it's a more sophisticated firewall, right? And it also works in a way which is different from the traditional, from the security group that we have seen, right? For example, this ACL has allow and deny rules, right? It has allow and deny rules, and the rules are created using a number, an ordered numbering, right? So you can have a rule which is 100, another rule which is 101, 102. You can also have gaps between the numbers, right? So you can have 100, rule 110, 120, etc., right? And the rules are evaluated in order, starting with the lowest number, right? And so you could have a rule which allows HTTP, for example. You can have a rule which allows SSH, for example, right? And the way it works is each packet is evaluated against the rules, starting with the lowest number. And if there's a match, right, no further rules are evaluated, right? And if there's no match, it takes the default rule, the one with the star, which is deny, right? So this basically denies any traffic for which there's no allow rule. But that's how it works. You can also control the inbound side, outbound side separately with ACLs, right? Now, if you look at the ACL for this default VPC, right, it basically allows all traffic. It's not really working, like it's not really doing anything. It says here, look, I'm going to allow all protocols, all ports, all sources to be allowed, right? Which basically means everything is allowed, right? This ACL is effectively disabled, right? So that's why this is, default VPC is not a good idea for production environments, because the rules are very permissive, they're very open, right? You need to change this. Ideally, you should delete this rule, rule 100, and create rules, specific rules to allow certain types of traffic. All right. Okay, folks. So we are looking at VPCs, right? We're looking at subnets, right? Within a subnet, we've looked at the routing table. We've looked at the ACL, which is a firewall, right? Let's also look at other components. For example, the internet gateway, right? This is the gateway which allows traffic to flow between VPCs in the internet, right? There's nothing to it, there's no configuration. It's just a component which you attach to a subnet via the route table, right? This is the internet gateway. You can have other things like NAT gateways, right? You can create a NAT gateway for a private subnet so that a private subnet can connect to the internet for software patches and similar requirements, right? So these are the main components, right? VPCs, subnets, route tables, right? There's internet gateways, there's NAT gateways, there are network ACLs, which we have seen, right? Firewall, and also there are the usual security groups as well. All right. So basically, I've done a walkthrough of the default VPC, right? Let me stop here. I know this is a little bit difficult, right? So let me know if you have any questions on the VPC, the various components, the various terms and terminologies, right? Let me know what it is that you don't understand, and then I will, implement one scenario. Right? I'll show you end to end how to create a VPC, how to install or how to deploy your servers on that VPC, and that will help you as well. All right, so let me start answering these questions, right? Please feel free, keep entering your questions, but let me start responding. Ranjit, what is the maximum VPC for an account? This you can look up, right? So these things I think keep changing, and I don't remember offhand, but VPC service limits, right? So look this up, and there will be some limit, right? But usually it's more than enough for most people, right? So you can see here it says you have 5 per region, right? 5 per region. But remember, you can always increase this, right? The reason they place these service limits is to make sure that no one company, right, one large company comes in and just takes up all the resources, right? There's nothing left for others. So it's just to control, right? Do things in a controlled manner, right? So if you want more, you can always talk to them, right? There's no it's only a soft limit, right? It's only a soft limit, but it looks like it's 5 per region. So 5 per region, right? You can always talk to them to increase this, right? And also, you don't need too many VPCs, right? In one VPC, you can have many different applications, right? Remember, it's a very big network, right? 65,000 IP addresses. So you can create many applications in the same VPC, right? You can also create many subnets. So basically the point is you may not need, right? You may not need too many VPCs. You can set up many applications in one VPC. All right. Okay. Jesus, VPC can be an Active Directory member or not. No. So Active Directory, is basically the authentication database, right? So a lot of companies have their Active Directory, have their users and usernames and passwords set up in Active Directory, right? So that's what I guess you're referring to. And can a VPC can be an Active Directory member? So so maybe, I'm not sure, exactly what the question is. So maybe, are you asking if Active Directory can be set up inside a VPC or not, right? Look, if your apps are in a VPC, right? If your apps are in a VPC, and you want the authentication, the user authentication, right, to happen via Active Directory, right? You can do some integration, right? You can basically do some integration where the authentication can happen via Active Directory, which is outside of a VPC, right? Or the Active Directory can be inside of a VPC as well, right? So the AD can be in the VPC or outside, right? And your application integration will have to take care of this, right? So I think it will work in both ways. There's no problem there. Right? Only the authentication bit, you can go to Active Directory outside of the VPC. Once the user is authenticated, you're connected to your applications in the VPC, right? That's possible. Or you can have the AD server within the VPC. So you have everything, all your components inside of the VPC, right? So both are possible. And right. So I hope I've understood your question correctly, right? And the authentication, by the way, right? So you don't need AD authentication to connect, right? To connect to a VPC. Right? To connect to a VPC, you need the SSH connectivity, right? You need user accounts on your Linux servers or Windows servers, right? So these may not go through the Active Directory as well, right? So yeah, so maybe you can just explain your question more, and then we'll come back to this. All right, Keshav, the main difference between NAT gateway and Internet gateway. Yeah, so Internet gateway is used for basically making a subnet into a public, right? Into a public subnet, right? So when you have an Internet gateway in the route table, it means you can connect to the servers in the public subnet from the internet, right? That's what an Internet gateway does. And a NAT gateway is actually used by the private subnet to connect to the internet, right? Only on the outbound side, right? And this is, for example, for downloading software patches, right? So the servers in the private subnet also need to connect to the internet, right, to download some stuff. But you don't want to allow someone to come into your private subnet, right? So you don't want inbound traffic, you want only outbound traffic, right? So that's what a NAT gateway does. So these are two different things. Internet gateway used by public subnets, NAT gateway used by private subnets. All right, Ranjit. Okay, question number one is, can I create one VPC on my account, personal, and another VPC in my in account 2, which is an office address, right? And can I do peering between the two VPCs? Answer is yes, you can, right? So you can peer VPCs belonging to two different AWS accounts. Yes, you can do that, right? And then the second question is, in my private cloud, I create each environment like production, QA, etc. in separate virtual LANs. So in AWS, this VLAN will be a VPC or a subnet. Yeah, it can be either, right? It can be either, right? It can be either. But I guess you should use subnets, right? I guess subnets are better because there's a limit on the VPCs, right? There may be some limit on subnets, but you can create many subnets, right? Subnets is better because you can create as many as you want, right? You can create as many subnets as you want, right? And if you don't want communication between these subnets, right, you can use the routing table, right? You can use the route tables for each subnet to block traffic from between these various environments, right? Between these various environments, you can also use ACLs and security groups to block traffic, right? So that you basically create a separation between these environments. Like in my case, I'll tell you, I have seen cases where the development servers have connected to the production database, right, and caused some damage, right? So normally you want to have a very good separation between your various environments, right? So what I would recommend, right, you can do many things, but what I would recommend, my recommendation is create separate VPCs. Let me correct this, right? So I think it's better if you have separate VPCs in separate regions, right? This is even better. And this is even better. So my recommendation is, create a development environment in, say, US East, create a production environment in US West, right? That is better, and this way you have separate VPCs as well, right? And you can peer them if there's a need to transfer some data, right? Especially you want data to go from production into development or test environments sometimes, right? So then you can create a peering between these environments. Keshav, communication among EC2 instances, what are the best ways? No, you can just connect, right? You can just connect. There's no within a VPC or a subnet, right? Just use IP addresses. Just use the private IP addresses. Don't use the public IP addresses, right? Just use private IP addresses, and whatever protocol that you want to do, right? Just use private addresses using whatever protocol you want to use. So, for example, if you want to do file transfer, right, maybe you can use SFTP, right? So you can even use HTTP to do some communication. So the routing table allows communication. There are private IP addresses, so you can connect. Yeah, so that's what, when you say access one from the other, right? So what you do is on the first one, right? What you can do is, for example, if you want to connect via SSH, right, to run some commands. So what you can do is connect from the first one, right? From the first server, run a command, something like this, which is you run a command which is SSH -I private key, right? Username @ private IP of second server, right? Something like this. So this way you can SSH to the other server and using the private IP of the second server, right? And it depends on what you want to do with the connection, right? This is a way to connect to the other server and run some commands on the second server. All right. Yeah, I hope that's clear. If not, please, you can ask a follow-up question if that's not clear. Yeah. Okay. So accessing one from the other, sharing resources. Again, I think it needs to be more specific, right? For me to answer it fully. But basically, the point is, right? The larger point is whatever you do today, right? Whatever you do today to share resources between servers, right? Outside of the cloud, right? You should be able to use the same, right? You should be able to do the same things inside a VPC in AWS, right? The same things you have to do, because AWS is not it's not changing anything at the standards level, at the protocol levels, right? These are just servers, same as the servers that you have in your own data center, right? So it should be the same thing. Okay, Ranjit, so cross-region VPC peering is possible. Yeah, I think so. Let's see, right? Maybe I'm wrong here. So VPC peering cross-region should be possible. Okay. So okay, it says here that VPC will be extended to cross-region in the future. This is as of 2014, right? Okay, and here, okay, as of 2011, 2014, it's not possible. Let me see here. Maybe it is possible now. Let's see. Okay, so I think even now it is only within a single region. So you're right, right? You're right. So I guess this solution will not work. So maybe you can create separate VPCs in the same region, or create separate VPCs in separate regions without peering, right? Without peering, you can use some other mechanism to transfer the data, right? So you can. So peering is not possible cross-region. So you can, you don't have to peer, right? You can get the data down into your own premises using a VPN connection, for example, and then transfer it to the other region, right? So you can do such things. So peering is not possible, but it is possible to transfer data without peering as well, right? Without peering as well, use indirectly. Indirectly, you can do that. So it's not possible at this time, but it is in the roadmap, right? Or maybe at least it is an open feature request. Okay, so this question here, you want to set up a master replication using MySQL database using a different region. So how will the data replication flow from one region to the other region? Data transfer over AWS private network or over the internet? No, so there is no AWS, there's no dedicated AWS network between AWS regions, right? So there's no like a direct connection between these regions, right? So it will be over the internet, right? So that's why I think your master replication will not really work because the latency is too high, right? You can have master slave maybe, but even there the slave server will have data. There'll be a lot of gap, right? There can be a lot of gap when you try to do replication across regions, right? So I don't know if it is a good idea to have a replication, MySQL replication across regions. So basically, MySQL replication across regions, right, might not be a good idea unless you are secondary server, right, or rather unless you are okay, right, unless you are okay with a lot of delays, right, a lot of lag in the replication, right? So there are some use cases where you can, for example, right, one interesting thing that let me just tell you here is you can consider using RDS read replicas. So here what happens is you can have out of the box solution where you can create read replicas in other regions from the master, right? And this is asynchronous replication. So the master does not wait for the data to be copied, right? So it's asynchronous replication, and the read replica will be created in another region. You can use it for read-only use cases. So this is potentially one solution you can think about. Right? Read replicas have other benefits also, by the way, right? You can use it for creating as a disaster recovery option, right? So if the primary fails, you can convert a read replica into the primary. So it's a good solution. You can think about it. All right. Okay. Next question. Can I create a site-to-site VPN connection between two regions? You can, I guess. So VPN, right? Can you basically, the question is, can you create a VPN connection between two networks? Let's say you have two offices, right? And without using the hardware, because you can't place a hardware connection, right? You can't place a hardware device in AWS, right? So can you create a software VPN connection between two networks in your two of your own networks, right? So that's the question. If yes, then you can do this as well, right? But otherwise, I'll have to think about this. Let's see here, 1 second. Let me just check on the console, right? So you have yeah, so let's come back to this, right? I think it'll take a bit of time to sort of experiment with this, but let's come back to this. It's an interesting one. Let me highlight this so that I remember this for later. Yeah, so this, the wizard has a third option to create a hardware VPN, but this is, for communication between your corporate network and the AWS VPC, right? So let's take a look at these scenarios a bit more. Yeah, so this is, basically communication between your corporate network and the VPC, right? That's what the VPN connection is for. Your question is, can we create a VPN connection between two different regions, right? So what we really need to find out is, can we have some sort of gateway in the other region, right, without peering, right? That's your question really. So we'll have to figure this out, right? I'm not really sure if it's possible, right? See, you can always over the internet, right? You can always use other protocols, right? Depends on what you're doing. So, for example, if you are doing some file transfer, let's say, right? If you're doing some file transfer, you can always use some secure protocol to do that transfer, right? So, so my question is, do we really need a VPN connection? Right? Do we really need a VPN connection? Right? It depends on what you're doing. So file transfers, example, file transfers can be done using secure file transfer protocols. So if you can just talk more about what you intend to do, right, between these two regions, maybe we can have a different solution and not just a VPN solution. Yeah, but okay, so that's what you're trying to do. What you're trying to do is you want to create another region instead of your corporate network. But look, a VPN connection, right? VPN connection is used for, is more like a always-on type of connection, right? Where you as a client, right, want to connect, right? Always-on type of connection, right? Where you want to connect to your resources, right? You want to connect to your resources, your users, right? Your users in your company want to connect to the apps on AWS, right? They want to use the apps using their browsers, right? That's what a VPN connection is for. So if you create a VPN connection between regions, right? It's not. I mean, that's not required. Right? VPN connection between regions is not required because you can't have users in another region, right? So maybe right for file transfer, etc., you don't need a VPN connection. Yeah. So okay. Can the replication happen over a secure protocol, right? What's the you might know more about this, right? I'm not sure about the replication protocols. So can the replication happen over a secure encrypted protocol? Right? So that's the question. Right? Maybe you don't need a VPN. So can replication happen over a secure protocol, right? If yes, then you don't need a VPN, right? All right, folks. So yeah, but you know, it is binary log shipping, right? But then, can the transfer happen over secure protocol? What's the protocol used for replication, right? So that's what we need to find out. Let's come back to this, right? I don't want to, these are kind of advanced questions, right? And I don't want to worry the others in the class too much, right? So let's come back. Let's come back to this. All right. Okay. So now let me, we've discussed VPCs, right? We've discussed the scenarios and the various components. Let me implement this, right? Let me implement this. Let me show you how all this works. We're basically going to implement, let's say, scenario. Let's say we'll implement scenario 2, right? Let's implement scenario 2, and I'm going to show you this from the console, right? And I'll use the VPC wizard, right? The VPC wizard. Okay. So our goal is to create scenario 2, right, which is one public and one private subnet, right? And you can create a VPC using these individual options in each area, right? So you can say create a VPC using this button. Then you can go and say create a subnet using this button. You can create a route table using this button, right? And then you have to sort of configure all these to work together, right? So you need to connect the route table to the right subnet. You need to create these rules manually, right? So you can do this by hand, right? But I would recommend that you don't, because it's a difficult topic, as you can see, right? So don't create it by hand. What you should do is go to the VPC dashboard. You'll find something called the VPC wizard, right? So use the VPC wizard because it will do the creation and configuration of all these various components automatically, right? Automatically. So this is a good idea, right? Don't try and do it yourself, at least initially, right? Unless you're a very experienced person in networking world, right? Okay. So what you do is you click on this VPC wizard, and then you have these 4 options here, right? You have VPC with a single public subnet. You have VPC with one public and one private subnet, and then the other 2, which are more corporate networks, right? So if you know 1 and 2, you are well on the way to learning 3 and 4, because 3 and 4 is basically the same thing with a VPN connection, right? Okay. So what I'm going to do is, all right, let's start something simple, right? Let's start with the VPC with a single public subnet, right? Let me create this VPC, and then we look at this VPC. What are the subnets? What are the routing rules? Where's the internet gateway, etc. Right? And then we will launch a server. We'll launch an EC2 instance in this public subnet, and we'll connect to it, right? And we'll connect to it from HTTP protocol as well, and then we'll see how it all works, right? Hopefully this demonstration will make things clearer for you. All right? Okay, let me use this wizard. What I'm going to do is I'm going to select option 1, scenario 1, right? And I'm going to give this a name. This VPC will have a name. Let's call it scenario 1, right? And you can see here, this is the IP address range of the VPC. It has a subnet mask of /16, which means there are around 65,000 IP addresses, right? And then there's a subnet, which is a public subnet, which has a subnet mask of /24, right? And this will have about 256 IP addresses, right? So this is a class B network. Within this class B network, which is a VPC, we have one public subnet, which is a class C network, right? So that's it. That's all you need to do. The wizard will do the work, right? You don't have to worry about anything. The wizard will create the routing table, the internet gateway. It will do the ACL, the rules of the ACL, etc. Right? Very, very simple. Very simple. Okay, so now you can see, right? The one that is selected right now is the default VPC, right? And the one above that, this one is the scenario 1 VPC that we have just created, right? It's very simple actually to create it, right? Okay, now in the subnets, we should now have 5 subnets, right? The 4 are from the default VPC, and the one on the top here is the public subnet that we have just created using the wizard, right? And here you can see the public subnet has been created in zone 1C, right? it has this IP address range, right, 10.0.0.0/24, right, and the route table has a rule for local traffic and a rule for external traffic using the internet gateway, right? Because we've used the wizard and we've said we want a public subnet, so the route table therefore has the internet gateway, right? And this is what makes this subnet a public subnet, right? You can find this internet gateway in this internet gateway section here, right? This one. The second one is our internet gateway for this new VPC, right? So you can see it's pretty simple, right? We have one VPC, it has one subnet, and the subnet is a public subnet. So now we can actually create a server in this public subnet and then try and connect to it, right? So let me go ahead and do that. Now, before I do that, I also should create the security group that will be used by the server, right? So what you should do is go to security groups, right? And you can create a new one. You can create a new security group. Let's call it scenario 1 web server security group, let's say, right? Because we're creating a web server in this public subnet, right? And the VPC has to be selected. So the security group will be used within this VPC only, right? So we select the VPC for which we are creating the security group, right? And now for this security group, we also need to specify the rules, right? We need to specify the rules here. So for example, you may want to connect via SSH, right? Via SSH. So I'm going to create a rule for SSH, and then maybe we also want to connect via HTTP. So we'll have to create a rule for that as well, right? So let's create a rule for SSH, and I'm going to create the source IP, right? The source IP for SSH should be my IP address, right? Not anything more than that. So what you can do is you can do what is my IP on Google. You'll find your public IP address, and this IP address can be set up as the source IP of for your SSH connectivity, right? And I give a mask of 32/32, which means it's one host, right? One server that will be connecting to this server from the outside, right? You can also enter your corporate network's IP address range using a different subnet mask, right? So a whole range can also be specified in the source IP address, right? So this will allow to the server SSH access from my machine, right, only at this moment. Now we'll create another rule, which is for HTTP, right? Let's say we want people to connect. It's a public website. We want people to connect to this on port 80, right? And the source IP here can be 0000/0, right? Which means any IP address, any external IP address. All right. So this is a security group which we are creating within this scenario 1 VPC, right? And we'll use this security group for our server when we launch it. All right. So let me go to EC2 now, and we launch a new server, right? And we launch this server in the VPC, right? So let me go to EC2 here, and let me launch this server. All right. I'm going to use Ubuntu, which is what I prefer, right? You can use any server, as you know. All right, and we use micro as usual. Micro server is also free tier eligible, right? And in this page, right, what we normally do is we use the default VPC, right? Use the default VPC, but instead now we'll use the new scenario 1 VPC that we have just created, right? So this is the big difference. And in the subnet, you normally have to select a subnet, but here there's only one subnet, right? There's only one subnet, so we just have to go with that selection, right? Okay. Now look at this one, right? What is happening here is no public IP address will be assigned to this server by default, right? Because that's the default behavior of a VPC. The VPC is meant to be a private network, right? You can change this if you like. If you like, you can change this, but by default, no public IP address will be available to this server, right? So there's no way for anybody to connect to this server from the outside. All right. Okay. Now we'll leave it at that, right? We'll make sure we'll not have any public IP. I'll set up a separate elastic IP address for this at a later point, right? For now, there's no public IP address. All right. One more thing that you should look at is the tenancy, right? The tenancy. So a private cloud is meant to be a dedicated infrastructure, right? So within a VPC, you have this option of either using shared infrastructure or having your own dedicated instances or host, right? So if you use dedicated, remember the cost will be much higher, right? But this may be required by your compliance needs, right? Regulations, your company policies may require the use of dedicated servers. So you can do that. You can do that if you like, right? And this is what also makes a VPC valuable to some companies, right? But if you're okay with shared, then that's what you should use because this will be cheaper. All right. Okay. So basically, what we're doing is we're launching a server, an EC2 instance, in the same way as we've done before, except this time we are selecting, a VPC that we have created. Right. This is a non-default VPC that we have created. All right. Everything else remains the same. Right. There's no difference. We do have to select our security group, right, which we have created. So in this VPC, we have this security group that we just created, right? So we'll select this one here. Right, and that's it. Everything else remains the same, and we'll launch this EC2 instance in this VPC that we have created. Right. Okay. Now you'll notice when the server comes up, right, there will be no public IP address. This is different from the default VPC behavior. Right. There will only be a private IP address. You can see here. This is the private IP address. Right. But you can't really connect to this, right? If I want to connect to this IP address, right? If I do something like this, let's say using the private IP, right? It won't work because this is a private IP. The internet does not know about this IP address. There's no way in which it can forward my request to the appropriate IP address, right? So you can't connect. There's no way for anybody to connect to this server because it is a private IP address. Right, so you can see right away that this is better. From a security point of view, the hackers, even if they know your IP address, they can't do anything because there's no route, there's no way for them to get into your server. Right, but what you can do is, if you want this, now we want this server to be a public server. It's a web server, right? So we can go and create Elastic IP, and Elastic IP will be a public IP address, right? So you can then associate the Elastic IP with the server, and then you can connect to this server, right? So what we'll do is we'll allocate a new Elastic IP, and then this IP address we will associate with our EC2 instance, which is running in this VPC, right? So this becomes a public IP address. Right? If you look at the instance, you can now see there is a public IP address, which is the same as the Elastic IP address. Right? So now I can connect to this. I can connect to this server using this command. Right? I'm able to connect to the server using this command. Because the security group allows access on SSH. Right? So this is the Ubuntu server. Right? You can see we have logged in. Right? You can run your usual Ubuntu commands. For example, I can run sudo apt-get update to update the software repositories so that I can install some stuff, right? So you can run your usual commands on this server, and we've been able to connect to this server, right? We've been able to connect to this server because the security group allows, right? You can see the security group here. It allows access over port 22 to my IP address, right? If you tried this, you'll not be able to connect because your IP is not allowed in the source IP address, right? And also, we are able to connect to this server because the VPC in which this server has been deployed has a public subnet, right? And the public subnet has an internet gateway, right? So this gateway is the one that is allowing us to connect to this EC2 instance, right? If you remove this rule, there will be no way in which you can connect to this server, right? So two things here. One is the route table and the internet gateway, and two, the security group, which is allowing access on port 22, right? So that's why we are able to connect to this server. Okay, now let's also, what I'll do is I'll also install Apache on this server, and which is a web server, and we'll try and test this server from port 80 as well, right? Let me just install Apache here, and then we'll test this server on port 80, right? So that's done. Let me disconnect. Let me exit my session here, and now we have Apache web server installed. So what we can do is we can use the public IP address, and on the browser, right, we can test if Apache is responding, right? This is the web server. You can see it is responding, and you can see it is responding. The reason it is responding is the firewall, right? The security group here allows access on port 80, right? Allows access on port 80, right? You can give this a try as well. See if you can access this, right? See if you can access this server, and also you can try and connect to this server using SSH, and you'll find that you're not able to use it. All right, so you can give this a try. I hope you can copy this IP address, or you can send me a message on the questions panel. I'll respond to it with the IP address if you want to try this IP address, right? So you can try this IP address on port 80. You can try it on port 22. See if you can connect to this server. All right, okay. But what we've seen so far, is how to use the VPC wizard, right, to create scenario 1 VPC, right? A scenario 1 VPC, and a scenario 1 VPC is basically this one here. Right? It's basically this one. There's one VPC. It has one subnet. The subnet is a public subnet, right? And therefore, you can connect to the server from the outside, from the internet, right? And here, when I'm connecting to this server, I'm actually connecting from the internet, from the outside, right? Let me stop here, and let's see if you have any questions on what we've seen so far. Now, Ranjit, you can look at this document. I just did a Google on doing replication using secure protocols, right? So there's a MySQL developer documentation which explains how you can do it using SSL, right? So there must be so there is a way, actually, right? You can see there is a way in which you can set up secure replication over for MySQL, right? So this is something you can try. And also peering, right? You don't really need peering between regions because you can also use public IP addresses, right? So so here, right, basically here you're saying cross-region VPC is not possible, cross-region peering is not possible, right? But I'll just add here that you can always use public IP addresses, right, in the two VPCs to communicate. Right, so peering is only required when you want to communicate using the private IP addresses, right? But here you can always use public IP addresses to communicate. So you're not really affected that much, right? Because there's no peering possible across regions. Okay, let's look at some of the other questions here. So Keshar, you have some EC2 instances and applications. Yeah, you can just explain this differently maybe. So you have some EC2 instances, and the applications are only accessible. You want them to be accessible only from local, from your corporate network, I guess, right? Is what you're saying. Okay, so you have a situation where you have EC2 instances in the VPC, and you want to create a solution where the applications and the EC2 instances are only available from your corporate network, right? Is that your question? Right. So then what you need to do is you need to, if that's the case, right, you need to create one of the other scenarios here, right? So you can use the wizard and you can create a scenario. For example, this one here, right? This is the one I guess that you want, right? So you have an EC2 instance in the VPC, right? And you have the applications installed on this, but you want this to be accessible only by your users in your company, right? Nobody else from the internet needs to access these EC2 instances, right? So this is scenario 4, right, that you can implement, and you need to implement a bit of this VPN connection, right? So this is a secure protocol over which you can access your private subnet, right? So just look at the wizard and use the scenario 4 when you launch your VPC. Right? So basically what you need to do is for apps that need to be accessed only from your network, right? Only from your corporate network, use scenario 4, right? Use scenario 4 in the VPC wizard, right? And the scenario 4 allows you to create, allows you to create a VPN connection, from your network to the VPC. right? So the application can only be accessed from your employees in your company, right? And nobody else can connect to the server. Yeah. All right. Okay, folks. Any other questions, right? Please let me know, right? I know this is a difficult topic, right? If you want me to repeat something, please let me know. If you want me to show you something, please let me know, right? What I'm going to do is I will also show you the scenario 2, right? Let's also look at scenario 2 so that you understand what's the difference between those two, right? We'll not see scenarios 3 and 4 because you need to get into VPN connections and so on, which is hard to show, right? But we look at scenario 2 as well after these questions. All right, Kesha, for VPN, do we have to use third-party software? Yeah, you know, there are free, I'm sure VPN clients, right? VPN clients, there are both free and commercial, right? Free and commercial are available. Maybe others in the group can give their opinions as well, right? What kind of VPN client can be used? There are also, you know, VPN hardware, right? There's VPN hardware which obviously has to be purchased, right? So there are many solutions around VPN. You have to explore this a bit. Yeah, it's a protocol. You know, VPN is a standard. It's a protocol. I'm sure there'll be many free VPN clients available, right? So it's not a problem. And commercial tools, maybe if you need some sophisticated requirements for VPN, maybe you can think about some commercial products. Yeah. So this comment, you know, thanks for this comment, by the way. Right, so you guys, you know, you can write your opinion as well, right? Because you can learn from each other as well, right? Not just from me. So please feel free to add your comments, like this one here. And what you say here is, Ranjit, what you say here is right? The software, the VPN client can be a software VPN client, or it can be a hardware one, right? And you can basically use either one. Now the hardware one presumably is better, right? It's faster, because a VPN basically is a protocol for encryption, right? So you need some processing capability to encrypt the data, and the hardware VPNs can do that faster, right? So that's the idea. And for professional needs, you probably have to go for some hardware type of clients, right? For most common, you know, general purpose needs, maybe a software client will be sufficient, and there will be both free and commercial software clients. The hardware client will obviously be a commercial product. Okay. Jesus, can a VPC be used as a server? No. So a VPC, right? A VPC is a network, actually, right? It's a network, much like your home network or your corporate network, right? So it's very similar to your much like your home network or your company network, right? So it's just a network, and within a VPC, you can deploy one or more servers, databases, etc. Right? Okay, so and I guess your question is a little bit different. What you're saying is, can a VPC be used only for servers, or can it be used for clients as well? Yeah, you can use it as a client as well. So, for example, one server in VPC A, right, can be a client to another server in VPC B, for example, right? Or it can be a client to another server in the same network as well, right? So so both are possible, right? But in general, right, you use cloud computing to set up your servers, right? And the clients are usually outside, right? So in general, AWS is used to set up server side servers, right? And then your clients. These could be SSH clients, these could be HTTP clients, etc. HTTP or SSH. They are usually outside of AWS, right? So in general, right? In general, your VPC will be used to host servers in general, right? But there could be some use cases where there may be a client running on a VPC as well. Yeah. So I hope that's clear, right? If not, please let me know. Okay, Kesha, you're saying you have set up software for that for the VPN client, but your question is there any VPN option on the AWS network? No. So what happens is, you know, when you use VPCs, right? When you use VPCs, you can see here there's something called VPN connections, and there's something called virtual private gateway and customer gateway, right? So this section here in the VPC console, right, is for VPN connections, right? And here you have you have these three components here, right? So there's a customer gateway, there's a virtual private gateway, and a VPN connection. So what happens is
when you configure your VPC, you need to, when you configure scenario 3 and 4, right, you need to configure a customer gateway, and you need to configure a virtual private gateway, right? So these are components which are sort of used to enable the VPN connection, right? So this is what you need to do, and you'll be able to then use a VPN client on your side, right, to connect to the VPC on the AWS cloud. Yeah, so that's the VPN option on AWS network. I hope that answers your question, right? So what I'm saying here is, when you use scenarios 3 and 4, right, you set up VPN connections between your network and the VPC, right? And the components required to set up the VPN connection is available in the VPC console, right? And these components are basically virtual private gateway, which is on the VPC side, right? Which is on the VPC side, and also the customer gateway, which is on the customer side, right? So these are some components. These are not hardware, right? They're just software components which you need to configure, and then you can have a VPN connection, right? You will need a VPN client, right? And as Ranjit has said, right, it can be a software client or a hardware client on your side, right? But from the server side, from the VPC side, AWS gives you everything, right, to be able to create a VPN connection. Yeah. So and Ranjit, your comment here is that hardware VPN is used to connect between two data centers, and software VPN is used to connect individual client machines, right? Yeah. Maybe you're right. So hardware in general, right? Hardware will probably encrypt faster, right? So hardware will probably encrypt faster, right? Encrypt and decrypt, right? Encrypt and decrypt faster. So it is probably used for high volume, right? High volume traffic, and that's why, as you say, right, between two data centers you'll have high volume, right? So that's where hardware is used. If you have a simple use case, you just have 1 or 2 users, then software should be sufficient, right? Software should be sufficient for single or few user light traffic scenarios. Okay, so Jesus, I understand your question now. What you're saying is, can you install some client, like client software on these servers? You can, right? So the question is, can you install? You need to see if these images are available, right? If these images are available. So, for example, let's say if you were to go to EC2, right, and if you were to launch a Windows instance, right? You want to launch a Windows instance here. So what you want is you want to find a Windows 8 ARMY here, right? Let's see. So Windows 8, right? You can see Windows 8 as such doesn't look like it's available. Normally you'll find Windows Server. So you can see here, these are the Windows servers, right? You can see Windows. There's only server options here. I don't think there is a client option available in the armies, right? In the armies. Now you may want to look at there are some other services available. For example, this set here. These are end user applications, right? So if you want desktops in the cloud, right? Maybe this is what you need. Right, so you can explore this one. This is more like software as a service, right? These are not servers; these are more clients where you have basically the desktop software on the cloud, right? So you can maybe look this up. I've not really explored this, right? But maybe you can look this up, right? It's called Workspaces, and this is enterprise software as a service applications. All right. So let me just write here that it does not look like you have Windows client armies, right, available when launching EC2 instances, right? So it's really meant for servers. That's the truth, right? But you can consider AWS's new offerings, which are end user enterprise applications, right? Especially look at AWS workspaces. Right, so these are desktops on the cloud, right? And you can check if Windows 8, 10, etc. is available. It could be available, right? It could be available. So you can check. I'll also check, right? And let's come back to this at some point. All right, okay, folks. So now let me show you one more thing, right? Just to reinforce this VPC concept, right? Let me show you how to set up scenario 2, right? Let's set up scenario 2. This one, scenario 2, is actually a VPC with 2 subnets, right? It's a VPC with 2 subnets. One subnet is public, and the other one is private, right? Other one is private. So we can set this up and take a look at what it looks like. All right, so what I'm going to do is I'll go to VPC here and I use the same wizard, right? I'll use the same wizard and I will select scenario 2 here, right? So this one is a 2 subnet VPC, one public and one private, right? Let's take a look at this. So what we'll do is here you can see in the wizard we can give it a name, scenario 2, right? And then there's one public subnet and one private subnet, right? Public simply means there'll be an internet gateway here, and private means there will be no internet gateway, right? And remember, there's a NAT gateway that we spoke about, right? NAT gateway. This is a way for private subnet servers to go out to the internet on the outbound side, right? So the NAT gateway requires an elastic IP address, right? So we need to create an elastic IP address first, and then we'll come back. We'll have to come back to this wizard and continue with the creation of the subnet, right? So let me just go out for a moment, create an elastic IP address for the NAT gateway, and then I'll come back to the wizard. All right, so this is a new elastic IP address, right? And we'll use this in our wizard. Okay, scenario 2, right? Scenario 2, let's give it a name, scenario 2. Right, and here you can specify the elastic IP address that we just created. Right, this is used by the NAT gateway for NAT purposes, network address translation purposes. All right, okay, so that's it. The wizard makes it easy, right? Always use the wizard because it's much simpler. There's no reason really to create VPCs by hand, right? Always use the wizard. Okay, now this will take a bit of time. This will take a bit of time because the NAT gateway is a managed service that needs to be provisioned. So stuff has to come up. Maybe stuff has to be installed, right? So this takes a bit of time, maybe a couple of minutes, and then your VPC scenario 2 will be ready, right? Scenario 1 was very fast because there was no NAT gateway being used. All right. Okay. At the end of this process, we'll have a VPC with 2 subnets, one public, one private. We'll take a look at both those subnets. We'll take a look at the routing table for both, right? One will have an internet gateway, the other will have a NAT gateway, right? In their routing tables, right? So now and then maybe we'll set up a server in the private subnet, right? And you'll have to think of how you're going to connect, right? How you can connect to that server in the private subnet. All right. Any moment now, right? This doesn't take that long. Any moment now, we should be ready. So what we're going to do is, we'll have this kind of VPC, right? We'll have this kind of VPC, and then you can have a server in the private subnet. But then the question is, how will you connect to this private subnet, right? There's no way from the outside to connect to this database server in the private subnet, right? Unless you have a VPN connection. So what you can do, right? What you can do, by the way, is you can SSH into the web server, right? And from the web server, you can connect to the database server using the private IP address of the database server, right? So you can go to the public subnet, and from there go into the private subnet, right? So this is an indirect way of connecting to your private servers without using a VPN connection, right? So that's what we'll try and see how to do something like this. All right. So now we have our VPC, right? We have our VPC. You can now see there are 3 VPCs, right? One is the default one, which is ready-made. We don't have to create this. Scenario 1 is the one we created earlier, right? And now this one is scenario 2, which has, by the way, you can see here, it has the same IP address, right, as the IP address of scenario 1, right? It has the same IP address range as IP address of scenario 1, and that's okay because both of these are isolated networks, right? These networks don't talk to each other, so it doesn't matter. It doesn't matter. There's no IP address conflict because there's no communication between these two networks, right? So so that's interesting to see that they both have the same IP address ranges. All right. Okay. Now, if you look at the subnets, right? If you look at the subnets, now we'll have many more subnets, right? First of all, these two, right? These two are the new ones that have just been created, right? These are scenario 2 VPCs, and you can see one of them is public and one of them is private, right? So if you look at the public subnet in the route table, you have the internet gateway, right? This is what makes it a public subnet, right? And if you look at the private subnet, you can see that the route table does not have the internet gateway, right? And instead, it has a NAT gateway. It has a NAT gateway, right? So this is required for outbound traffic only, right? And the internet gateway allows traffic both ways, inbound and outbound, right? So that's the only difference, right? You now have a VPC with two subnets, one which has an internet gateway. This is the public one, and another one which has a NAT gateway. This is the private one, right? That's it. That's how it works, right? Now, when you launch your RDS instances, when you launch EC2 instances, you can place them in the appropriate subnet, right? You can place them in either the public subnet or the private subnet, right? So let's take a look at that. So let's say you want to install EC2 instances in the private subnet, right? So what you can do is you can launch from here and specify the private subnet. Before that, let me just create a security group, right? Let me create a security group for the new VPC. So I'm going to create two security groups, actually, one for the public subnet, one for the private subnet. So let's call this scenario 2 DB security group, right? This is for the private subnet because our database is going to be in the private subnet, right? So there's a security group for the private subnet, and I'm going to create another one which is for the web server on the public subnet, right? So let me create another one. Let's call this scenario 2 web security group, right? This is going to be for the servers in the public subnet, right? Okay, so so now we need to set up the rules as well, right? We need to set up the rules as well. So for example, for the web server, right? For the web security group, we'll have our usual rules. One is SSH, right? One is SSH, and let me get my IP address here again, right? So so this is my IP address with /32 subnet mask, right? Please remember the /32 is what you need to specify when you're setting up your IP address, right? And so this becomes a way for me to connect to this server in the public subnet, right? Now the other security group in the private subnet, right, needs different kinds of rules, right? So here we won't have SSH, right? We won't have this rule because you can't connect to the server in the private subnet in any case, right? There's no need, there's no use for SSH, right? But what you want is, you may want to connect to this server from a server in the public subnet, right? So what you can do is you can allow access on port 22 from the public subnet, right? So you can select the security group of the public subnet here, right, as the source IP, right? So we're not saying 0000/0. We're not giving my IP address, right? We are saying anybody from the public subnet using this security group, right, the web server security group, can connect to this server, to the server in the private subnet on port 22. Right? Normally what you'll do is you'll not have port 22, you'll have say a database port, right? Normally you'll have a database port, let's say MySQL, you'll have MySQL port, right, from the web server, right? Or maybe if you're using some other database, maybe Microsoft SQL, right? You'll have this kind of rule allowed from the web server security group, right? So this is how you set up the security group for the database server in the private subnet. Yeah, I hope this is clear, right? So we are setting up two security groups, one for servers in the public subnet and another one for servers in the private subnet, right? Okay, now if you're launching a server in the private subnet, what you're going to do is the same things, right, as we've done before, except here we choose scenario 2 VPC and we choose a private subnet for our database server, right? This is where a database will reside, right? Okay, everything else remains the same. The security group will have to be the one we just created, which is the database security group, right? Okay, so so this is our private server, our database server, right? So this is our database server. Now, so what we've done in the scenario 2 here is we've just launched EC2 instance, which is our database server in the private subnet, right? This is what we've done. Now you can't connect to it directly, right? You can't connect to it directly. So what you have to do is you have to create another server in the public subnet, connect to that, right? Connect to that over SSH. From here, you can connect to the database, right? Over the database port, over SSH, because this security group here, right? This security group here allows traffic from the public subnet security groups, right? So all these servers which are in the same security group can connect to the database from here into the private subnet, right? So this is one way for you to connect to the databases. All right. Okay. Let me stop here. Do you have any more questions on VPC? Please let me know. Remember that it's a difficult topic, but it has to be learned. You have to learn it because you have to use it. Right? It's becoming the default way of setting up infrastructure in AWS. All right. Now I have one more topic to cover, right, which is the direct connect, but we don't need too much time. It's basically a network service for dedicated connections. So we'll spend maybe 5 minutes on that, right? But otherwise, please let me know if you have questions on VPC. If you want me to show you something again, please let me know as well. Okay. So Jesus, please repeat the step for the public IP, right? For the public IP address. And okay, sure. So what we're doing is, let's say in scenario 2, right? The same is applicable to scenario 1 as well, right? So what you do is you want a public IP address only for servers which need connections from the internet, right? If you don't have that, you don't need public IP addresses, right? For example, your database server does not need public IP because nobody needs to connect to the database from the internet, right? So that's point number 1, that public IP is only required for public-facing servers, right? Typically web servers, right? So what we can do is you can install a server, you can deploy a server in the public subnet, right? And then you have the internet gateway which allows traffic from the outside, right? But you also need to be able to access this server. You also need a public IP address on the server, right? Because when you do something like this, right? When you connect to a server using the public IP address, right? When you use the IP address to connect to a server, it needs to be a public IP because only public IP addresses are known to the internet service providers, and they know how to route the traffic, right? They know how to send the traffic to the right server if it is a public IP address, right? If it is a private IP, they don't know where to send the traffic, right? So that's why without a public IP, you cannot connect to any server from the internet, right? So what we would normally do is in the public subnet, right? It makes sense to have public IP only in the public subnet, right? So create a server in the public subnet, assign a public IP address to it. You can assign an elastic IP, for example, right, which is also a public IP, and then you can use that elastic IP in your SSH commands. You can use it in the browser, etc. Right. So let me show this to you once again because I want to make sure that these aspects are understood. Right. So let me launch one more instance. Right. Let's launch the instance once again. And what we're going to do is, let's say this is your web server, right? And what we're going to do here is you can choose either of these VPCs, right? VPC scenario 1 or VPC scenario 2, and make sure that you are creating your web server in the public subnet, right? Because there's a way for you to reach the servers in the public subnet. There's no way for you to reach the private subnet, right? So make sure you're launching the server in the VPC and in the public subnet, right? Okay, now here, by default, a public IP address is not assigned, right? It's not assigned to servers in the VPC, right? You can change this. You can say, hey, this is a web server. This is a server in the public subnet. I do want a public IP address, right? So you can enable this, and a public IP address will be assigned, right? Or you can use elastic IP addresses instead because they are more permanent, right? It's always better to use elastic IP addresses instead of these public IP addresses, right? So I'm going to keep it at disabled, right? It's better to keep this disabled and go separately and assign the elastic IP address, right? Okay, so that's what this is. Basically, we're creating a server in the public subnet. We're not assigning public IP addresses at the moment, right? You need to have a proper security group which allows access, right, on whatever port you want, right? So if you want HTTP port, it should be allowed in the security group. If you want SSH, it should be allowed in the security group, right? So this is important. All right, and that's it, right? That's it. So otherwise, you just launch the EC2 instance using your usual settings, right? And now this server won't have a public IP address because we selected not to have it, right? It has a private IP address, but this is useless when it comes to connecting to it from the outside, right? So what you need to do is you need to create an elastic IP address. So we're going to create a third one here, and this IP address, this one here, right, will associate with our new server here, right? Let me find out which server it is, right? We now have 3 servers, so let me go back and find out which server it is that we need to use. So it looks like this one. It's C560, right? So let me go back and associate this new elastic IP with our new server here, right? So this is how you associate an elastic IP to the server, and now this server has a public IP, right, which also happens to be an elastic IP, which is more permanent, right, which is more permanent than a public IP, right? So now that you have a public IP, you can now connect to this, right? You can connect to this from the outside. So my computer here is the outside, right? I'm connecting to the server over the internet, right? So now you can connect to this server using this elastic IP address. Yeah. Okay. So let me summarize this as well. This is very important. I want to make sure that this is clear. So basically, what you do is step 1, use or rather launch EC2 instance in the public subnet first of all, right? Public subnet, because this allows access from the internet, right? Without a public subnet, you can't connect. Secondly, use an elastic IP, or rather what you do is you allocate an elastic IP, right? And after that, you associate the elastic IP with the EC2 instance. This gives the instance a public IP address, right? Now, this public IP or elastic IP, right, which is also public by the way, right, can be used to connect to your server on any port that the security group allows, right? So in the meantime, you also have to have you have to have a security group as well, right? So make sure. Let me add one more point here. Let's say 1.5. Create a security group which allows traffic on ports like 2280, right, 443, which is for SSL. I'm sorry. So these you need a security group as well, right? And then once you have all this, then you can connect to your server. For example, for SSH connectivity, you can use a command like this: SSH -I private key, right? Then username @ elastic IP address, right? So this is how it is done. All right. Okay. Ranjit, can you show a demo of the software VPN server configuration to connect to VPC? With this setup, we can connect. With this setup, we can connect to all the web, the web layer, JBoss layer, and DB layers directly from the client PC. Yeah. So this will take a bit of time, but it's a good question, right? It's a good question. Let's come back to this. Maybe in one of the subsequent sessions, we'll take a look at this. By the way, we have module 10, right? By the way, we have module 10 where we have time for Q&A, right? So that'll be the last module where we'll spend a lot of time on any sort of Q&A that you guys want to do in a later module, right? But I guess it's important, right? We should do this. Let me highlight this as well. All right, and one more question, and then let's maybe spend time on direct connect, right? So Ranjit, how do I allow private subnet machines to connect to specific public URLs? Specific public URLs, right? So you can't really do that unless you create some sort of filtering software, right? See, the firewall, you have really two mechanisms, right? You have security group and you have ACLs, right? Which can only control protocol, which is stuff like TCP, UDP. It can only control ports, right? And it can control the destination, the source IP addresses, right? You can only control these things. Maybe you can enter the source IP, right? So source IP may be a solution. Right? This may be a solution. If you know the IP address of that URL, maybe you can block it there, right? Otherwise, for outgoing traffic, you probably have to look at some specialized software which filters based on URL, right? Like, for example, in companies, right, you have these proxy servers, right? In companies, you have these proxy servers which are used to limit. For example, in corporate environment, right? In corporate environments, you have proxy servers which are used to filter, right? URLs, filter or block URLs, right? So you need that kind of mechanism. There's nothing in the AWS infrastructure which allows you to do things at a URL level, right? You can do at protocol, port, and source destination. Source IP is the same as destination for outbound, right? So you can control only these things. All right. Okay, folks. So yeah, I know this was a difficult topic, right? I hope you've understood at least enough to get going with this, right? You can at least get started with VPCs. And remember, you have to do it, right? You have to do it because it is becoming mandatory, right? It's becoming mandatory. All right. Okay. We have 5 more minutes. Let me spend this on another topic here, which is direct connect, right? And this is, what we're trying to do here is we're trying to cover the major topic and then spend a little bit of time on topics which are relevant for enterprises, right? And one of these is direct connect. It's not very important, right? It's not likely that you'll use direct connect, right? Unless you're a very big company and you have a clear need for it, right? But it's important as a solutions architect to know about these things, because you may want to introduce these things in some use cases that you are trying to tackle, right? Okay, so direct connect, it's basically a dedicated network which bypasses the internet, right? It bypasses the internet. So you have like a dedicated, like a leased line. Here in India, you call these things leased lines, right? So it's a dedicated connection between your corporate network and the AWS cloud, right? And you have different speeds. You have 1 gigabit or 10 gigabit capacity possible, right? And basically, it's a connection between your routers and the routers on the AWS side, right? And what it gives you is it might reduce your bandwidth cost, right? Because your existing internet connection may be more expensive, right? You need to work these things out. You need to work on the costs of direct connect versus your existing connection, but it might be cheaper, right? 2, it will give you consistent network performance, right? This is important because if you use your existing internet connection, you are contending with your existing internet traffic, right? Maybe your employees are using some applications, they're using their email, right? They're doing their browsing. So when you use the same internet connection, there is contention, right? You are affecting them, and those users are affecting your traffic, right? So if you use direct connect, you get consistent network performance, right? Consistent network performance, right? So lower cost, consistent network performance are probably the reasons, right? Why you may want to go for a direct connect, right? Okay, these are some costings. So there's depends on the speed, right? What speed you want, and obviously the greater the speed, the higher the cost, right? So these options are available, and yeah, that's it, right? So please look it up. In fact, if you look at there's good documentation available. Let me just show this to you. Okay, so this is AWS documentation, and by the way, it's the let me point out a few pieces of documentation which you should look at, right? So first thing you should look at is what is called the product overview, right? This is the product page, AWS Direct Connect, right? Gives you a brief introduction to the service, right? You can look this up, and then if you are interested, you can look at product details, right? This has real important the finer details of that service, right? So you can look at this. For example, the Direct Connect detail page will tell you what's possible here in India, right? Obviously, Western countries will be well supported, but in India as well, right? You have this one here in Mumbai, right? In Mumbai, you have this option of Direct Connect, right? So it's not available in any other place. It's only available in Mumbai, right? So so look at the product details, and if you want to understand more, look at the FAQs, right? FAQs are a great resource because these have some of the more complex, also some of the more commonly asked questions, right? Look at FAQs for all the products that you are interested in. All right, okay. So that's it, folks. That's it from me for today, right? What we'll do in the next week is we'll look at storage services I'm sorry, we'll look at databases, right? We'll look at databases like RDS, and we'll also look at high availability auto-scaling groups, load balancers, and such. All right, so that's coming up next week. All right, so thanks for joining, right? And have a good week. I'll see you next Saturday.